Welcome to Bald Guy Sci. In this episode, we're going to be taking a look at members of an ecological community and how they interact with one another. So this is the second video in our ecology series. So if you missed the first video, go ahead and click that link that's going to be right up here on your screen, and you can go ahead and check that out. But if you're all good to go, let's jump right into it. This is community interactions in the ecosystem. Mother Teresa once said, "I alone cannot change the world, but I can cast a stone across the waters to create many ripples." She knew that her actions, noble and benevolent, could influence the actions of others, and that though she may never directly tell someone to act or choose something better, they'd have the example and inspiration to do so. Well, underlying this thought is a truth about communities. No one acts in isolation. No one's choices only impact themselves. Well, this is true in our own journeys in life. It's also true in the ecological communities within the ecosystem. So since ecosystems are made up of living and non-living components, biotic and abiotic respectively, we can look at how organisms within the community respond to those factors, whether they are stable or constantly changing. So when we look at how organisms interact with the ecosystem as a whole, we could talk about adaptation and natural selection. Well, these two ideas help us to understand who comes out on top in this sometimes brutal ecological cage match. Well, an organism that's stronger, healthier, or generally better adapted to the ecosystem has a much better chance of survival. In other words, it's more fit for survival and therefore more likely to pass on those genetics that are fit in that environment. Well, this survival of the fittest is the best for the overall long-term survival of the species, as well as the success of a specific population within the community. So when we consider this survival of the fittest model, we must consider that there are three types of interactions to consider. So competition, predation, and symbiosis. Now, we'll get more into predation and symbiosis a little bit later, but the factors that contribute to competition are the things we want to check out right now. Hey guys, I'm out here in Whetstone Gulf State Park in upstate New York, and it's kind of like a late spring day. Nice day out, but it's a little cool. I want to show you these down here. These are wild leeks, sometimes referred to as ramps. But these wild leeks, these ramps, are only here for a limited time. They don't grow year-round. And the reason for that is that their habitat changes pretty drastically when the leaves come out above us. So right now they have abundant sunlight and resources, and they don't have a lot of competitors. But pretty soon these trees, which are way better adapted at competing for the light, are going to spread out those broad leaves. They're going to steal the sunlight, and these guys are going to die off for the season because they lose those resources that they need to survive. So these ecosystems that we're talking about are constantly changing throughout the seasons and varying those conditions, or what we call limiting factors, that allow certain organisms to compete better than others. So the wild leeks that you saw sprawling all over that hillside were doing that not to compete with the maple trees above, an example of intraspecific competition, but to avoid competing with one another, or intraspecific competition. So in this case, we see that there are two different types of competition. One that happens within a species and one that happens between different species. So a dandelion
must be the last one of the season.
Spreads its seeds by the wind. It does that to decrease the likelihood that it'll be competing with itself. So the parent wants to get its offspring a little further away to make them more successful. When an acorn drops right to the forest floor underneath its parent tree, it has a pretty poor chance of competing with its own parent for the very sunlight that it needs to become a full-grown tree. Make sense? So it relies on other animals to disperse that acorn, that seed, like a squirrel, to bury it some distance away. That's all about competing or not competing with one another in order to be more fit for survival. Okay, so organisms in the community compete with one another for all sorts of limited resources. And those competitions can be pretty passive, like the leeks and the trees, right? Each taking their turn within a season for the sunlight that's available. Or they can be pretty brutal, like hyenas.
Hyenas. I hate hyenas.
That are fighting with a lion or another animal for a particular kill. Speaking of killing, when an animal kills and eats another member of the community for its food, we call this the second one of those, predation.
Come on, come on. Kill me, I'm here, kill me!
Now, where the predator is feeding on the prey, you can notice that a predator species tend to have lower populations than their prey species. Well, this is because it's much easier to hunt a blade of grass, herbivores don't hunt them, than it is to hunt an antelope.
But Dad, don't we eat the antelope?
So organisms can interact by competing with one another or by preying on one another. The third type is a form of cooperation between organisms that we call symbiosis, or to do life together. There are three types of symbiosis, but they all have one thing in common. They benefit at least one of the organism in that relationship. So to illustrate this, you have this famous picture of the flower and the bee, right? The bee is getting nectar from the flower as it moves from flower to flower. It carries a little bit of pollen with it. So the bee gets food, the flower gets pollinated, which helps it produce seeds to reproduce. So this benefits both organisms. And so we call that mutualism. It's mutually beneficial. You see, the flower only makes the nectar for the express purpose of attracting that bee so that it can be pollinated. The flower doesn't need the nectar for any other purpose, but it's not harmed by the bee either. So what if the bee was harming the flower? That relationship that would exist if the bee was harming the flower is a second type of symbiosis that we call parasitism. So these monkeys that you see here are grooming one another. They're looking for ticks. No, these kind of ticks.
Hi everyone, welcome to Air.
But ticks and other organisms like them make their living at the expense of a host. So the monkeys may not be harmed much, but they are harmed, making them a host. And that makes the tick the parasite. But monkeys actually provide us with a great example of the last form of symbiosis called commensalism. So as this monkey uses a vine to move through the forest canopy, it doesn't harm the vines and the trees, but it doesn't help them either. So we would say that they don't really get anything good or anything bad from the interaction. So when an organism neither benefits nor harms, we call that commensalism. So when organisms in the community interact, they do so in a variety of ways, but each interaction depends on the organisms that it involves, and sometimes their individual population densities. Now, population density is a term that describes, very much like the density of matter that you may have heard about in the past, how closely packed the individuals of a species are. So just like the equation for density is mass over volume, the amount of matter packed into a certain space. In order to figure out population density, you need the number of the organisms in the population and then how much space that they take up. So that is how we describe population density. So if a bear lives in an area where trout populations are low, it may have to work harder as a predator or move along and try to find a food source that isn't quite as scarce. But if the bear population density is high, it's going to have a much greater chance for competition with other bears in that search for the same limited resource. So it might actually compete with other organisms that are still trying to prey on the same food source. So like this eagle swooping down is competing for the same limited resource. So the population density of wild leeks that we saw earlier is one of the highest I've ever seen in my life. And the reason for that is that those leeks are trying to not compete with one another. All right, well, that does it for our second video in the ecology series, Community Interactions. And if you missed the first one, you can always go check that out right here. And remember to give this video a like, a share, and if you haven't yet, click that little subscribe button and the notification bell to be notified when each of our videos drops. So don't forget to check back next week when we're going to be looking at cycles that exist within the resources in an ecosystem. We'll see you later.